Hello, my name is Simon. Welcome to ALS Programming. This is the Hello World project, the OXOO.C Hello World project. Alright, so the first thing you need to do is to look at your resources, right? So you can see in this section, they said for this project, we expect you to look at this concept. It is important you actually look at this to give you the concept and understanding of what you need to do. This is also a video resources. You can also look at it. You need to play it. It will sharpen your understanding. Then here is read or watch. This is also important. You can see everything you need to know. To start with, C. It's a PDF file. You need to also read it. And this also talk about Dennis Ritchie. You need to look into it as well. Alright, so basically you need to look at all the resources, okay, so that you have a concrete understanding. Then the next thing you want to do is the objective, right? So you need to ask yourself these questions when you are done with the resources. You need to make sure you understand the resources and be able to answer these questions without making any research, without going to the book itself. Alright, so another section I want you to take note of is this requirement. This is very important, right? So the allowed editor is VI, Vim, and Emac. For me, I'll be using Vim. Okay, so the second one says all your files will be compiled using Ubuntu 20.04 LTS using the GCC command. So if you have read the documentation, the resources, you should know what GCC is. However, I'm still going to talk about it. I'm going to give a clear explanation of how it works and examples. Okay, so the next one says all your files should end with a new line. Okay, so the next one says a readme.md file should be at the root of your repo containing a description of the repository. And you can see this is two readme file. I want you to take note, a readme.md file at the root of the folder of this project containing the description of the project. So this is quite confusing, alright? So but let me just make it straightforward. So for example, let me just give you an example of this. So for example, let me scroll down. For example, you can see this is the directory of the project. Let me open my terminal and give you an example of it. So let me create a directory called example and cd into it. Alright, you can see there's nothing in my example folder. So in the directory of the project, right? So if this is the directory of the project, what you want to do is you're going to create a directory. Then when you create the directory, you should go inside the directory. Sorry, before you go into the directory, the current one should be the ALX low-level programming language. So there should be a readme file. So you can create a readme file here like this, readme.md file, right? So if you check it now, we have a readme file. Then it should not be empty. It should not be empty. You should actually put what you want to do inside the readme file. You explain what you are doing in the readme file. So next you should go inside the o.oo-hello world, and you should also have your readme file here. So if we check here now, you see we have a readme file here, and if we check the previous one, we also have a readme file in the root folder. Okay, so I think that is clear. So if we go back here to our example, if you list this, you can see we have a readme file here, and inside this folder we also have another readme file. So I think that is clear. So let me just give an overview of the resources. Alright, so ALX Software Engineering, the OXC Hello World program. So the first you need to look at is comments. So a comment is a program readable explanation or annotation in the source code of a computer program. They are added with the purpose of making the source code easier for humans to understand, are generally ignored by compilers and interpreters. Alright, so you can see the example of a single line comment here. This is an example of a single line comment. It starts with a forward slash and the asterisk, and it also ends with the asterisk and forward slash. Okay, for multi-line comments, you can see the example here at the bottom. I believe you must have seen this in your resources. Okay, so the next one is GCC. So what is GCC? GCC stands for GNU Compiler Collection. GCC is an integrated distribution of compilers for several major programming languages. This language currently includes C, C++, Objective-C, Objective-C++, Java, and Fortran, and many others. Okay. So by default, the GNU compiler collection is available for Linux. I don't know of other OX. So for example, if we go to my terminal, I can do gcc-help -help. All right, you can see I already have GCC in my system. It came with it, and you can also check the version of your Linux machine by doing lxb_release-a. If you type that, you can see my own is Ubuntu 22.04. Alright, so in the resources, if you can remember, they said your code is going to be compiled using Ubuntu 20. Okay, so now how GCC works. Okay, the first step is processing. So the source code is being expanded through macros. Comments are removed and include a process. Okay, the second step is compilation. The process code is translated into assembly code for the target architecture. The third step is assembly. The assembly code is then translated into machine code, which is the binary code. Then the fourth step is linking. The object file is generated in previous step are combined with libraries to produce an executable program, which is the fifth one is loader. Load the executable program into the memory and begin execution. So with all that, let us go to the quiz before we look at one or two examples. Alright, so from the resources we read, you're going to ask to actually point out the answer in what you've learned so far. So the first question says, what is the common extension for C header file? We have to obviously we all know that the header file is .h. You can see is here. Okay, if you look at this, you can see this is it here. So the next one says, what is the common extension for C source file? Of course, we know every C source file is .c. Okay. Okay, so if I scroll down a little, alright, so if we scroll down a little, you can see what are the different steps to form an executable file from C source code. Okay, so if we look at that, this is the correct answer, which is processing, compilation, assembly, and linking. I just gave the example a few minutes ago. So in which category belong the C programming language? It is a compiled language, because every program we write, we need to compile it. We need to what? Compile it. Okay, so if we scroll down to this, and which of the following are both valid comment syntax in INCC and Betty compliant? Okay, you can see for this this is a single line comment and this is a multi-line comment. Okay, for this the rest are what? Wrong. Alright, that's for that. So if you scroll down, which command can be used to compile C source file? Of course, we've talked about this is the GCC. GCC is what we use to compile the file. Alright, so let's do some example on, let's do like one or two examples here. Alright, so the first task is O processor, which is what? Processor. Alright, so for this you need to read it clearly. You need to read it and understand clearly what needs to be done. So it says write a script that run a C file through the preprocessor and save the result into another file. Okay, so the C file name will be saved in the variable file. The output should be saved in the file. Alright, so for this task we have to create a file called o.processor. Okay, so let me go to my terminal and let me go to my cloud terminal and let me show some example. So I want to SSH to my terminal. You can also use the web SSH. You have different options you can use, but I prefer to use the SSH because it's kind of real, and the web SSH do have errors. Sometimes when you type a long line, it gives you some kind of error. The later got string together and you kind of confuse what you are typing. So if you SSH this, I'm going to copy my password, come back here and paste it. Okay, I'm going to expand my terminal. Yes, I'm in. So pwd, where am I? Say I'm in slash, I'm in the root directory, right? So if I go to root and ALX low level programming, okay, if I list everything that is here, you can see this is the project. So I want to go to the first project, which is the current project that we are. Okay, hello world. So if I list this, alright, so the first thing I want to do, let me create a directory, for example. Okay, I want to enter the example folder. Okay, so you can see in the new folder I just created, it's currently empty. Alright, so if we go back to the question, it says write a script that runs a C file through the preprocessor. Alright, I want you to take note of this. They've given us a file already, which is main.c, and this is the content of the file. This file is what we are going to use to test the program we've written so far. Alright, so let's just create this file. You can just copy the name of the file, or you can write it. Let me write it. So main.c. So let me copy what we have here. Ensure you are copying the right thing, you know, from the end curly brace to the header. So I'm going to right click, I'm going to do Ctrl C, then here right click and paste. Okay, escape and write and quit. So if you check now, we now have the main.c file, and you can also check what is inside. You can see we're having exact same file here. Alright, so the next thing we want to do is to export the file, right? We want to export the file just like they said here. You can see the C file name will be saved in the variable C file. So I want to run this command here. Okay, so the next thing I want to do, we need this file, which is this file here, right? So let me copy what we have, what I have written before. So I will just do this by O dash and copy it here, copy from previous folder and put it in the current folder. So if you check now, we now have the old processor file, the old dash preprocessor file. Alright, so the next command we have to run is this here. Alright, so we're going to copy the command and paste it here, and we expect it to generate a result. So let me run this. Okay, let me check what happens. Okay, so you can see we now have what? A C file. I didn't create this file, but the last command I ran actually generated the C file. So you can see the next command you want to run is tail-c. So if you do tail-c, right, so you can see we are having a kind of almost the same result here. You can see this is what we have here, almost the same result we have here. That is when you've known you have done it correctly. Okay, so basically you should try and grab the step I took in creating this. Alright, so when you are done, you should, let me see, sorry, remember there is no readme here. Make sure you have a readme in your root directory. You can see it here. Make sure you have a readme in your root directory and in your project directory. In every directory you create, there should be a readme.md file that explains what you are doing. Alright, so, and the readme should not be empty. Okay, so the next thing we want to do is, so the next thing for you to do is to add, then push your GitHub. So you can just do git add, then git commit, and so on and so forth. Then you push your GitHub. So when you're done pushing to your GitHub, you want to click on this check your code. So you can click on it, and it's going to check if you've done the right thing. So most times you get error, and make sure you fix your errors, then try again. You should be successful. So let us go to the second one, which is compiler, which is one.compiler. So this one says write a script that compiles a C file but does not link. Okay, write a script that compiles a C file but does not link. So the C file name will be saved in the variable C file. The output file should be named the same as the C file, but with the extension .o instead of .c. Okay, so an example, if the C file is main.c, the output file should be main.0. Alright, so the first command we want to run here, you can see I already have the main.c file. You can see, remember we already have a main.c file here. So I want to run this first command, which what this first command does is the C file name will be saved in the variable C file. So I'm going to press enter. Okay, the next command we want to run is main.c, right? So we already have it. This is just to check if what the main.c file is intact. You can see this is it, main entry point. We already have it here. So this is your solution is going to be on this one-compiler. So if you look at it, this is the name of the file, right? So I already have it. I'll just copy it from the previous one I wrote, one-compiler, and put it here. Okay, so if we check now, you can see we have it here. So now we want to check if everything we've written is okay. So but let me just let me look into the 1.zip file. Let us look into the 1.zip file and see what we got. You can see, so this command here, what it does is it compiles the C file but does not link it. Okay, so let's see it in action. So now we want to run this command. Okay, so I'm going to copy this and paste. Okay, so if we check, it looks like nothing happened, but actually something is happening at the background. Okay, so if you can see, we now have what the main.o file. We now have the main.o file, so it meets the criteria for the second requirement. So it says the output file should be named the same as C file. So it means the last requirement. Example, if the C file is main.c, the output should be main.o. You can see the C file is what main.c and the output is what main.o. Alright, so for that I think we need to run one last command. Okay, the last command we need to run is this. So I'm going to copy this and run. You can see we're having exact same result here. This is how you know you've actually done well. Okay, so that for that. So you know, after running it well, the next thing you want to do is you want to do your git add, git commit, git push to GitHub, and click on check here to check if you've done everything well. So if you are getting error, that means you've done something wrong. So you should watch my step closely and make sure you are actually doing the right thing. Okay, so this is just an example, so I'm going to remove this folder. Okay, I should remove everything. Okay, so for that that is okay. I will not cover the rest of the example. What this example 1 and 2 I've done so far will give you a guideline of how you can solve your project, if you can work on the project. Okay, so however, you're going to find a link to my GitHub account whereby you can look into it and follow the same example. It gives you a clear picture how you can solve this project. So thank you very much. That is all from this video. I will see you in another video. I wish you success in your endeavors.